Okay, here we go. Lesson 8-2. This is going to be example 1 and 2 together. We're graphing exponential functions and we're doing the translation of them with the a, h, and k coefficients all in the same video. We're going to stair-step process through all of these graphs so you can see what happens to the anchor point on each one. And I want to let you know that we go left to right to find out what to do to each anchor. Okay, first is y equals 2 to the x. There's no a coefficient, so we know our anchor is right here at 0, 1. Okay, just to put in a couple other points, I happen to know that 1 is going to be at 2, and -1 is going to be at 1/2. 2 goes up here to 4, and we'll kind of draw this right here. And there it goes. Rough approximation. The graph on the notes, oops, no arrowhead. The graph on the notes is much better. Now, same thing, but now we're adding an A. This is just to illustrate what happens to a basic anchor graph if I add an A. All you have to do is move left to right. Move this number, this y coordinate, it's 1, multiply it by 4. So that's going to be 4. So it goes to right here. Okay, and then every coordinate on here moves up the same amount. So it would keep decreasing and go up like that. It would just shift it, all multiply everything by 4. Okay, now the next one is the red ink. We do the same thing, we multiplied by 4, so we moved our anchor up to 4, but then h always lies. H is always attached to the x. H always lies, that's +5. It's going to move this anchor back to the left 5. 1, 2, 3, 4, 5. So we find our anchor like that. And then again, it's just a translation of the blue one to the left. So it kind of goes like that. Okay? And then we throw all of them. We have an A, we have an H, and we have a K all together right here. So we go left to right. First we multiply our anchor times 4. Then we move it to the left 5. And then we move this anchor down 3. 1, 2, 3. So it becomes just a translation of this one down 3. And it would kind of look like this. Okay, again, you can see it on the graph. Oops, no arrowheads again. Old habits die hard. Now, these are all exponential growth. So is the purple and orange. They're exponential growth because the b factor is greater than 1. The problem is we have to flip it down. So you have to think of these graphs right here, take the whole thing and flip it down like that. So the graph is going to go like this. So let's take our A, we know it starts at 1, multiply it by -3. So 1 times -3 is -3. Okay, and then the graph kind of goes like this. Grows, but it grows negative. Dang it. Okay, and let's do all the translations together with the orange one. We flip it down and move it to the right 4 and then up 5. So we flip down our anchor first, and then the x minus 4 says move right 4, 1, 2, 3, 4, and then move that anchor up 5. 1, 2, 3, 4, 5. And you'll see this graph on the notes as well, and this one kind of goes like this. No arrowhead this time. Like that. Good news, bad news about this is all exponential growth stuff. So you have to remember it goes up to the right or down to the right for exponential growth. What happens if it's decay? This is a generic decay with its anchor still right there at 0, 1. Remember what decay looks like. It goes this way and towards the asymptote. And the left-hand part of the graph would go like that. And you would have to know how to move this anchor just with the decay graph using all the same A, H, and K principles that I showed you right here.